Hey, my name is Sergeant Patino. I'm a paramedic student from class FM28. The reason of this video is to make a really quick review on easy drug calculations. So, a lot of us have a really hard time with this, but I think it's way easier than we make it out to be. I use inequalities to understand math. Understanding inequalities and ratio has helped me a lot when it comes to drug dosage calculations. And I want to try to convey this little formula that I have developed in the last couple years. So I want to start just with an easy problem. I think that if we start really easy and start building up, it will help us make connections better. So let's just start here. So let's say every problem will be given as an order from the doctor. The doctor asks you to give this, and you have the medication in this form. And it's on us to figure the next step. For example, let's say the doctor wants us to do Tylenol, 1 gram. And we have Tylenol in pill form. Each pill is 500 milligrams. An important thing to know here, and it's something that I'm not really going to dive into it, is to know conversions. You have to know your conversions. You have to know what a milligram is, what a milliliter is, and what's the relationship between a milligram and a gram. In this case, 1 gram is 1,000 milligrams. Okay, so now we have the doctor's order to give 1,000 milligrams, and we have 500 milligram pills. So this is when the formula gets pretty exciting. So, like I was telling you before, every formula has 3 components. From those 3 components, 2 of them are directly related to each other, and they are they represent a ratio. So, in this problem, we know for sure that 1 pill equals 500 milligrams. What we do not know is how many pills will equal 1,000 milligrams. I know most of you in your head are already thinking of what the answer is, but I want you to stop there for a sec and just focus on formulating this problem and writing it down. So, we're talking about relationships. 1 pill is 500. However, we do not know how many pills is going to be 1,000. The biggest thing of this problem is knowing how to, of this formula, is knowing how to set it up. On one side of the formula, we're going to have all the equal units. Like you can see here, we have pills on this side and milligrams on this side. The top part is always going to have the information that we know. And the bottom part is going to be missing 1 component. That component we're going to mark with an X. The next thing we do is find this lonely factor right here, multiply it over and across, and then across again. So multiply and divide. So multiply from here to here and divide to this number. This is what I mean. 1,000 milligrams times 1 pill equals 1,000. That number, 1,000, divided by 500. This is when it gets super complex. So, I don't like dealing with zeros, and I don't like dealing with long numbers like this. Every time you have a division with a lot of zeros, you can eliminate them. So you will eliminate the same amount of zeros inside the square and outside. So here we eliminate 2 on each side, and then we know that 2 times 5 is 10. The answer to this problem is right here. So the X equals 2. 2 pills. Okay? If the doctor wants us to do 1,000 milligrams of Tylenol and it's dispensed in 500 milligrams pills, we need 2. right? Too easy. I knew you in your head knew the answer, but this is super basic. And if you get this formula here, it will help you when you have drip calculations. So from this problem, we're going to move to one more difficult one. Okay, sometimes in a problem they show you a picture of a syringe. I have it on this upper corner, hopefully you can see it right. And the problem says the syringe has 0.5 milliliters of morphine. The other thing they will give you is that the concentration of morphine is 10 milligrams per milliliter. Again, the first thing we need to do is identify the known information and the relationships. We know for sure that 1 milliliter of morphine has 10 milligrams. The question is asking us to solve the amount of milligrams in 0.5. Like I was telling you before, one side of the equation is going to have the milliliters and the other one is going to have the milligrams. So this side, we're going to say 0.5, which is the information that's given to us, but we have no clue how many milligrams this is. The top part is going to be the relationship, and the bottom one is going to have an unknown value. Okay? So this unknown value is what we're solving for. What we're going to do is multiply this times 10 and divide this way. So 10 times 0.5, the answer is 5. Divided by 1, and the answer is 5, right? So we know now, we know now the amount of milligrams that we have in 0.5 mLs of this medication. Okay? So 1 whole ml has 10 milligrams, half of it has 5. Does it make sense? Following this equation. Now, I know you guys think it's still an easy process, and you probably could have done this in your head. Let's move to a more different problem here. Let's say the doctor orders 1,500 mLs of B5W to be given in over 12 hours. So, we are going to set up the formula the same way. We're going to find our 3 knowns. In that particular problem, which is right here, 1,500 and 12 hours. That's our direct relationship. So we're going to have 1,500 equals 12 hours. mLs. Equals 12 hours. How many mLs do we have in 1 hour? Same thing, we just multiply 1 times 1,500 and divide by 12. So we know this is going to be 1,500, and we're going to divide by 12. That's 125 mLs. Okay? Too easy. This is mLs in 1 hour. Okay? Now, if you want to get more complex or more detailed, or if they ask you a minute, you can say, I have 125 mLs in 1 hour, which is the same thing as 60 minutes. How many mLs I'm going to have in a minute? Same setup. 1 times 125 divided by 60. Okay? And you can do the math on that one. They usually don't ask you things like that. They will ask you more milliliters per hour. But it's the same. The point I'm trying to make is the same formula. These last 3 problems were pretty much exactly, they were kind of different problems, but they have the same factors. 3 knowns and find 4 unknown. Same formula. So cool, it's pretty easy. I like this because I don't have to remember the order of things. I don't need to remember all that stuff. And when you're busy and when you have to find these rates, you don't have time to write your desired over half times drop factor and all that stuff. Speaking of drop factor, so every IV tubing is designed differently. They are designed to deliver a certain amount of volume over certain drops. Okay? The ones we are very familiar with is 60 drops per ml. That's the one we usually use all the time. They have 4. So there's a system that delivers 60 drops per ml, 20 drops per ml, 15, and 10. So you need to remember that, and there are questions that I will ask you. For example, a question will say, deliver 1,000 mLs of normal saline in 8 hours, and find how many drops per minute you have to set up your system at. This is a 3-step problem. So let me repeat the question so make sure we all get it right. The doctor wants us to infuse 1,000 mLs of normal saline solution. Actually, of 0.5 is half. 1,000 mLs of half normal solution in 8 hours. The first thing we need to do is find how much of that is per hour. I'm going to come back to my formula, and it says 1,000 mLs. It's in 8 hours. How many mLs? It's an hour. So then we multiply 1 times 1,000 divided by 8. And if we divide 1,000 by 8, it comes to 30 mLs an hour. That's how much we're supposed to be pushing. Now, the tricky part, find how many drops per minute. This is where it gets super easy. Okay, so let's say the doctor wants us to infuse 31 milliliters an hour using a 60 drop set factor, or a drop factor of 60 drops per ml. Okay, so our drop factor is 60 drops per ml. Every time, and this is one of my tricks, every time someone asks you to infuse anything over an hour using a 60 drops drop factor, the only thing you do is, let me explain this a little better so you can get the grasp of it. So 31 mLs an hour, and we have 60 drops per ml. Okay? So what we're going to do is make this hour into minutes. So 1 hour has 60 minutes. What I like about this problem, what I like about this setup, is that we are going to cross off whatever it's equal. Whatever has a pair, we're going to cross it off. 60, gone, gone, mLs are gone, and mLs are gone. So we end up with 31 drops per minute. And that's an answer. That's our answer. It's pretty simple, right? Now, let's say that few questions will ask you to use a 60 drop factor because it's this easy. So, because few questions will ask you to use this kind of drop factor, they will usually ask you a little harder. They'll ask you to use a 15 drop factor. Let's use the same problem. The doctor wants us to do 31 mLs an hour using a 15 drops factor. So, the first thing we do is solve for 60 drops, which we know what the answer is going to be already. Now, we know that 15 goes into 60 4 times. So that's a factor of 4. Because 15 is a smaller number, we're going to divide this answer by 4. Okay? So 31 divided by 4. And this comes to 7 point something. Actually, 28, 3. So it comes to like 7.6, so it rounds up to 8. So our answer will be 8 drops per minute. Okay? Is it clear?
Mm-hmm.
Pretty simple, right?
Mm-hmm.
Are you tracking on it?
Mm-hmm.
Okay. So I'm not confusing you so far. Perfect. So far, we've been using this formula, the same formula, to solve different types of problems. Okay, so now I want to give you one of the hardest problems you might get in a test, in a drug dosage calculation test. So, let's say the order says the doctor wants us to do 5 milligrams of diltiazem an hour. And we are using a drop factor of 60. Okay. So a couple of steps with this one. Now, we know that this medication, a part of the problem has to give us a concentration of the medication. So the concentration of the medication, say, is 125 milligrams. 125 milligrams are dissolved in 100 mLs of normal saline solution. Okay, so this is also, you have to take a couple of steps to answer this question. The first thing you need to do is identify what would they want us to find. They want us to find drops per milliliter. I mean, they want us to find the drops per minute using a 60 drops per milliliter set. So to solve this problem, the first thing we need to do is we need to find out how many milliliters is 5 milligrams. So we can set up a formula. So our first direct relationship is we know for sure that every 100 mLs of normal saline solution have 125 milligrams. We know that for sure. And we want to know how many milliliters we need to have 5 milligrams of the medication, right? Like we did before, multiply and divide. So 500 divided by 125. We can do it a couple ways. We can do 500 over 25, 125. This one is easy because I already know there's a factor of 5 here. So let's divide this by 5. If we divide 125 by 5, it's 25. And this is 100. And I know that 25 goes into 100 4 times. So the answer to that division is 4. What that 4 is telling us that every 4 milliliters of this solution has 5 milligrams of the drug. Okay? So that's part 1 of this problem.
Not bad.
No. So let me erase this. So now the order changes a little. Now they want us to do 4 milliliters an hour using a 60 drop per milliliter factor. I'm pretty sure you have the answer in your head already. You know the answer? So, like I was saying before, we're going to make this 60 minutes and using a 60 drops per ml tubing. What we do is cancel the ones that are equal, and we end up with 4 drops over minutes. That's it. And this is really as hard as it gets. Once you have the concentration in mLs, you can find whatever. Now, let's say if they want you to do, let's say the doctor for some reason wants to know how many mLs you're going to give in an hour? Well, we just multiply this number. We just divide this number. Because if we're given 4 mLs in an hour, how many? Let's do the formula again. So the doctor wants us to know how many milliliters we infused in 30 minutes of this same problem. So we know for sure that every hour we're infusing 4 mLs. We have no clue how many mLs we're infusing in 0.5 hours. Does that make sense? So we multiply across and divide by 1. And the answer is 2 mLs every half an hour. Does that make sense? This is just as hard as it can get. Let's say, for some reason, that instead of using a 60 drops per minute factor, they want us to use a 20 drops per minute factor. Well, the first thing we do is find the mLs right here. Then we find how many drops per minute we will get using a 60 drop factor, and then we divide that number by 3. Right? In this case, it will be a small fraction because, we don't like numbers. We won't do that today. But you get the point, okay? This is it. This is my review for dosage calculation. If you notice, there's nothing to remember. There's no plug in here, move this way, nothing. Just know what they are asking for you to find and move it so you can get there. Simple. I gave you 4 examples that are very common in tests. And I don't know, hopefully this is helpful. Thank you so much. Have a good day.